Hello, my name's Oriana Bretschker, and welcome to Wastewater Wednesday. So today we're going to talk about sludge. But first, let me ask, does sludge management got you down? Is this a problem for you and your facility? Is it costly? Is there a lot of chemicals associated with it? Do you have to haul this stuff away much more frequently than you want to? Well, there is a solution that generates far less sludge than what you might be used to, and we're going to get into that a little bit more. But first, let's start off with the challenge. Why do you even get sludge in the first place? Well, all biological treatment requires biomass. We need microbes to grow, to run all of these activities which remove the pollutants from the water. Conventional treatment usually takes advantage of aeration technologies. That means you're blowing air into water, and the microbes are consuming that air in the water, as well as consuming the pollutants in the water. And in these processes, they grow more and more and more of themselves. And that more and more of themselves, right, is wasted sludge, right? It's extra biomass that you have to take out. Now, before you can actually send it anywhere, you actually also want to remove the water. And so there's dewatering processes after you've collected your sludge. So you don't have to haul mostly water, and you're only hauling away the solids, right? So you can save some cost and you save some volume. But in order to do that, you have to thicken your sludge. And this is an addition of chemicals. So this could be iron chloride. It could be a polymer. You also may want to, coagulate and sink and then thicken. There's a lot of approaches that will help you manage the sludge thickness. But any change upstream to what's happening with your biology can also affect how your sludge is going to settle out and ultimately dewater. So that's also super important to understand and be able to optimize. Now, once you get your sludge collected, right, and you get the water out of it, now you've got still kind of a slurry or a cake that you have to dispose of. And depending on where you're operating, this slurry or cake may have to go to a landfill, or maybe it could go to compost, or maybe it can't go anywhere that's close to you and you have to pay for that trucking cost. So sludge management can be very cumbersome. In an anaerobic system, you're going to generate less sludge, right? Because the microbes are not growing as fast as they do in an aerobic system. But you still have sludge. And this sludge can be even more challenging because the microbes that grow under these conditions to fix CO2 to methane are really robust, and they don't always settle out as easily. And so thickening that sludge and dewatering that sludge can really bring in some challenges. How do you mitigate these things? Well, first, let's try out a system that doesn't generate much sludge to begin with. And let me tell you how that happens. So in the bioelectrochemical treatment technology that Aquacycl offers, we need biomass. So we grow that biomass when we first commission the system as a biofilm attached to the internal surfaces in each one of our reactors. Now, we keep a really friendly condition to our microbes while we are enriching for this biomass. But then, once that biofilm is established, we start stressing them out because we don't want them to grow anymore. We just want them to work. And so what we do is we actually change how they respire. And we do that based on a resistor that we're applying across the circuit and how much energy we're actually drawing out of the system as DC power. Now, when we're drawing a lot of current or more electrons away from those biofilms, we're forcing them to respire really quickly, to work really hard. They're running really fast on that treadmill, but they aren't able to grow because we're stealing that energy away from them. So they're very active, but they're not growing, which means we don't get a lot of extra biomass. We don't get a lot of that sludge. And since we've been operating commercially over the last 2.5 years, removing 1,600 pounds a day through our bioelectrochemical treatment system, we've actually only had to remove sludge from that system once. And it was a minimal volume. When we did remove everything, it was only 4 IVC totes, so maybe about 1,200 gallons of sludge, and it was mostly water. And so if we were to thicken it and dewater it, it would have only been buckets worth of sludge after 2.5 years of operation. Now you compare that to the other technologies on the market, they have to remove sludge daily. And so this really de-risks your operations. It saves you cost, it saves you headache, it really simplifies. And the best part is when sludge removal has to happen, we take care of it. It's part of our service. We will remove it, we will dewater it if needed, and we will send it to where it's permitted to go. And we'll do that on the basis of our data, showing us in real time when that sludge has got to go. Find out more at aquacycl.com.